Assalamu alaikum. Now this is second part of topic momentum. Actually, this is linear momentum I'm talking about. Okay, there is another type of momentum. We call it angular momentum that will be discussed later on, not in this video. Okay, because it's not for O levels and A levels. Okay, so we will be studying in this topic only about the linear momentum. First video was uploaded and that was related to only the simple definition of momentum, impulse, and Newton's second law of motion. Okay, but this video is having further detail. That is, we are going further ahead. We are talking about law of conservation of momentum. Okay, so what does this law say? The momentum is conserved in any collision or explosion provided no external forces act on the colliding or exploding bodies. Okay, what does that mean? Momentum is conserved in any collision, like two cars are colliding with each other, two walls are colliding with each other. Okay, and the total momentum before the collision will remain equal to the total momentum after collision. Okay, what does total momentum before collision and after collision mean? Like here, suppose the yellow car was in motion and it collides with green, and that in turn will collide with blue. And then finally, all of them stop and the red car gets a push and starts moving. Okay, so now the initial momentum of yellow car will be equal to the momentum of red car later on. Like after collision, the yellow car stops and this red car starts moving. Okay, so the total momentum remains conserved here. Will be other examples I will be discussing in this topic. Okay, so in order to tell you about the law, here I will give the example of two bodies which are in motion. Okay, suppose this is body 1. Okay, M1. Body of course has a mass because momentum is a characteristic of a moving body. When body is in motion, of course body has mass. Body is moving, so body has a momentum. So suppose it is moving initially with the velocity u1. Okay, u1 may be 2 meters per second. Okay, and this is M2. This is moving in this direction, and suppose M2 is also moving in this direction with the velocity U2. U is actually the symbol of initial velocity. Okay, so body 2, velocity U2, and suppose this is equal to 1 meter per second. So of course, body M1 is moving faster, and it collides with body 2. Suppose the masses are M1 is 2 kg and M2 is 1 kg, and they collide with each other. Of course, they will apply force on each other, equal and opposite forces according to Newton's third law of motion. And suppose they continue moving in the same direction now. So after collision, what happens? M2, it has final velocity V2, and M1, it has new velocity V1. Okay, so total momentum will remain conserved. What is the total momentum before collision? Before collision of the two bodies, because both are in motion in the beginning. So M1U1 plus M2U2. Okay, and after collision, it remains conserved, means that will be equal to the final momentum. Final momentum will be what? Product of mass of M1 and its velocity V1 plus product of mass of M2 and its velocity V2. Okay, so this total momentum will remain the same. We will discuss more about this case in the numerical in the problem coming ahead. And here, it is not necessary that the two bodies will be in motion from the very beginning. One more body may be at rest in the beginning, another body may be moving. Okay, so that is also possible. Two bodies may be moving in the opposite direction also. That is also the possibility. Okay, so all examples we will be discussing in this video today. Okay, so here, what does external force mean here? In the absence of any external force, what do we call that type of system? Isolated system. Okay. So here the external force could be the friction. Okay, suppose the bodies are moving on the table, so we have to ignore the friction or air resistance. Okay, or any other external force has to be ignored. Okay, so in the absence of external force, the total momentum m1u1 plus m2u2 will be equal to total momentum after collision, that is m1v1 plus m2 into b2. So we will be applying this formula of conservation of this is, you may call it formula of conservation of momentum, and you may call it formula 1. Okay, and let us have some example here. Here, this is the example, question number 1. One body is at rest in the beginning and another body is moving with the velocity 1.2 meter per second. Body 1 has the mass 0.5 kg and body 2 has a mass 1.5 kg. The truck of mass 0.5 kg moving at 1.2 meter per second collides and remains attached to the another initially stationary truck of mass 1.5 kg. Okay, so heavy truck is in the that is B, it is at rest in the beginning and this truck is colliding. So, and they remain attached to each other. So what will be the common velocity? Okay, so here, let us see what is to be done. Total momentum before collision, let us check. Because body B has zero momentum. Why it has zero momentum? Because it is at rest in the beginning. So momentum of truck B is 0 initial momentum and momentum of truck A is 0.5 its mass and its velocity 1.2, that is 0.6 kilogram into meter per second. As you know, the momentum, the unit of momentum is kg meter per second. So 1.5 kg truck, it has 0 velocity, so its momentum is 0. So to initial total momentum is 0.6 kilogram meter per second. So total momentum after collision will also be the same. Okay. So momentum is conserved in the collision. So total momentum after collision will also be 0.6 kg meter per second. So total momentum will be mass into velocity. Now, if you see the previous example in the question, it's written they remain attached to each other. Means they move like one body. It means their masses will be added together. So 0.5 kg plus 1.5 kg total mass is now 2 kg. Okay, so 2 kg and they have now the common velocity. So what will be the common velocity with which they move? That is 0.6 divided by 2 is 0.3 meter per second. Okay, so collision may be elastic or inelastic. So this is actually inelastic collision. Okay, we will check it later on. What does that mean? What is the difference between elastic and inelastic collision? Whether the collision is elastic or inelastic, remember, the momentum will remain conserved, but the kinetic energy will not remain conserved. That will be less than before. Okay, because that is transformed into any other form that may be converted into elastic potential energy due to deformation of the bodies, and it may be converted into heat and sound energy also. Okay, so kinetic energy will be less than before. Now we have, before we go to discuss the question number 2, I just give you the picture of what we have discussed. Was the picture saying? This is truck A. Its mass was 0.5 kg and it was moving with 1.2 meter per second. This is truck B, which is heavier. Its mass is 1.5 kg. After collision, what is happening? They join. It means there may be, they get stuck up with each other and move like one body. Okay, like this. So their masses, they have the common velocity. M1 which is 0.5 kg, and M2. So the formula becomes what? M1 U1 plus M2 U2 is equal to M1 plus M2, because now they have the common velocity. They are moving like single body in the forward direction. So we write V. Okay, and since the initial velocity of truck B is 0, so this part will be vanished from the equation because this momentum is 0. So the formula becomes M1 U1 is equal to M1 plus M2 into V. You may call it formula 2. Okay, now let us go back to the second question of the discussion. So this numerical is already solved. Now question 2. A train wagon of mass 800 kilogram moving at 4 meter per second collides and remains attached to another wagon of mass 1200 kg that is moving in the same direction at 2 meter per second. Okay, now this was also in motion in the beginning. Okay, calculate the common velocity after collision. First body was moving at 4 meter per second. That is why it is able to catch up the second body of 1200 kg. Okay, and that was moving with 2 meter per second. Now they have the common velocity. The initial momentum of body 2 is not 0 here in this case. Okay, so how this is solved? P into mv. 800 kilogram wagon, what is its velocity? 4 meter per second. So its momentum is 32 kg meter per second. And what about the truck? Mass of truck was 1200 kg and its velocity was 2 meter per second. So this momentum is 2400 kg meter per second. So what is the total momentum? We add up. Okay. In the previous example, the first momentum of second body was 0. Only the first body was having momentum before the collision. Okay. So here the total initial momentum we add up and we get the answer for 5600 kg meter per second. Now momentum is conserved. So it means total momentum after collision will also be 5600 kg meter per second. Okay, so total momentum after collision is also this. So total momentum is equal to total mass. Their masses will be now added because they move again like a single body. Okay, so the total mass will be 1200 plus 800 means 2000 kg. Okay, and common velocity is to be found out. What was the initial total momentum? 5600 kg meter per second. Okay, so 2000 kg into V. What V comes? V is equal to 5600 divided by 2000, 2.8 meter per second. This is the common velocity with which the two bodies will be moving. Now here there are some answers to be filled in. The momentum of an object is equal to its dash multiplied by its dash. Its velocity momentum has dash the same as the velocity and is measured in kg. Okay, we have already discussed these type of things. So you have to fill up by selecting the words from this. Okay, so it's what will come in the first blank? Mass multiplied by its velocity. Momentum has, of course, direction will come in this blank. Same velocity, direction is the same as that of the velocity with which the body was moving. Kilogram meter per second in any interaction of bodies when no external what acts? Force. Okay, act on the system, the momentum is conserved. Okay, in snooker, a head-on collision of a white ball with a red ball can result in the red ball moving off with the dash initial velocity of the white ball, same velocity. This is an example of elastic collision and conservation of momentum. Okay. Now let us discuss about head-on collision. In this case, head-on collision means bodies are moving in the opposite direction. Okay, and total energy is transferred. One direction is treated as positive and the other is negative. That we already discussed in the previous video also. Okay, direction of, if you are taking right side, rightward direction positive means leftward direction will be taken negative. Okay, and now the two bodies, if they move towards each other, we have to take care of the sign convention. A car of mass 1000 kg moving at 20 meter per second makes a head-on collision with a lorry of mass 2000 kg moving at 16 meter per second. Calculate their common velocity after collision if they remain attached. So in this example, again, they remain attached to each other after collision and they move with the same like they move like the single body, and it means their masses will be added. So what will be the total mass after collision? 1000 plus 2000, that is 3000 kg. Okay, so what will be the common velocity that we have to work out? But remember, we have to take care of the sign here. Okay, so if you are taking right direction, that is direction of car, 20 meter per second as positive. So direction of lorry will be taken as negative. Okay. So, and afterwards, what will be the direction of their combined motion? We have to check the answer. If answer comes negative, means the direction will be leftward. If answer comes positive, means direction will be rightward. Okay, so total momentum before collision. Car's momentum, we are taking right positive. Car was moving in the rightward direction. So this is the multiplication of 20 into 1000 is 20,000 kg meter per second. And lorry 2000 kg and we are taking minus 16. Okay, so its momentum is 32,000 kg meter per second. So what is the total momentum? It will be subtracted now. Okay, because one is positive, the other one is negative. The total momentum of the two bodies, car and lorry, before collision is minus 1200 kg meter per second. Okay, after collision, the momentum will remain conserved and they move like one body. Okay, so that will also be minus 1200 kg meter per second. Okay, let us see the total momentum, that is total mass into velocity. Total mass is 3000 and momentum is this. Okay, 12,000 minus 12,000 divided by 3000 will give us minus 4. Direction is coming negative. Now it means after collision, the two bodies, lorry and truck, will be moving in the direction of lorry, that is towards the left side. Okay, minus sign shows that the bodies will be moving towards left side. Okay, now another question, a car of mass 1000 kg. This is moving at 30 meter per second, makes a head-on collision with a lorry of mass 2000 kg, moving at 15 meter per second. Calculate their common velocity after collision if they remain attached to each other. Again, they remain attached to each other. So let us check. Car's mass was 1000, velocity was 30. So mass into velocity, 30,000 kg meter per second. Lorry was moving in the opposite direction. So sign is negative, minus 15. So this is 30,000. So what will happen after collision? So momentum, if they add up, that is 0. Means they will come to total initial momentum is 0. It means total final momentum will also be 0. Okay. Total initial momentum, though they are in motion, but total initial momentum is 0. What will happen after collision? They remain attached to each other. And what will happen? Will they move? They will not move. Okay, after the collision, because the final momentum is going to come 0 meter per second equal to the initial momentum. Explosions. Before explosion, total momentum is 0 because what comes in the example of explosion? Rifle and bullet, okay, cannonball and cannon, okay, when cannon is inside, cannonball is inside and both of them are at rest, ball and the cannon, they are at rest. So momentum is 0. But after the cannon ball is fired, the ball moves in leftward direction and that will apply a push on the cannon and cannon will move towards the right side. Okay, so total momentum before collision is 0. So total momentum after collision will also be 0. Okay, momentum is conserved. So total momentum will also be 0. This means that the different parts of exploding body must move off in different direction. Okay, for the momentum to be conserved, because total momentum is 0. It means one body should move after the collision. For the answer to be 0, momentum of cannonball should be equal to the momentum of the cannon. Okay, it means one has to be positive momentum and one has to be having negative momentum. Then answer will be equal to 0. Okay, this is an example, the numerical example. And artillery gun of mass 15,000 kg fires a shell of mass 20 kg at a velocity of 150 meter per second. Calculate the recoil velocity of the gun. Here, Newton's third law of motion is applied here beside the momentum. Okay, while this shell is fired, the force will be acting in the opposite direction on the gun, and gun will recoil in the backward direction. Okay, so what will be the recoil velocity of this? So this is the direction of motion. If shell's velocity is taken positive, that is towards right side, then this velocity will be negative, that is towards the left side. So total momentum before and after the explosion is 0. MV shell, it moves with velocity of 150 meter per second. Mass is 20 kg, so its momentum towards the right side is 3000 kg meter per second. Now, the momentum of gun will also be the same, okay, but it will be in the opposite direction. So we know the mass of the gun that is given in the question. So total momentum of the gun should also be 3000, okay. So gun's mass was 1500 kg. So what is the velocity? Mass into velocity. Momentum will also be 3000 and negative, okay, in the opposite direction. So what will be the velocity? That will be 2 meter per second in the opposite direction, that is minus. Okay? Because the gun is heavy, so its velocity is smaller. So mass into velocity of gun will be equal to the mass into velocity of the shell. Okay, so that gun will recoil in the backward direction, that is left, okay, with a velocity of 2 meter per second. Now, a girl of mass 60 kg throws a boy of mass 90 kg out of the swimming pool at a velocity of 2 meter per second. Okay, what is the girl's recoil velocity? Of course, when they move, the girl's force on the boy will be action, and the boy's force on the girl will be reaction. So they will move in the boy, if he moves forward, the girl will be moving in the backward direction. Okay. So this will be the case after the collision. Boy 90 into 2, 180. That should cancel the momentum of the girl. Mass of the girl is 60. So the momentum of the boy is 180. The girl will gain momentum in the opposite direction. Okay, so 60 into girl's recoil velocity, that will be equal to the momentum of the girl. So the girl recoils with the velocity of 3 meter per second. Minus sign shows that it will be moving in the opposite direction to that of boy. Okay, so with 3 meter per second. Okay, before we discuss the further detail of this, I will explain a few points about this. That is the action and reaction here. The girl applies force on the boy. Okay, so F is equal to ma. Okay, boy gains momentum in the forward direction. He accelerates because initially boy was at rest. So initial velocity was 0. Now he gains the velocity in the forward direction. Okay, so the boy accelerates, and the force applied by girl is F is equal to ma. And at the same time, same force will be applied by boy on the girl. Okay, so this is action reaction forces. Okay, girl's force on the boy will be equal to boy's force on the girl, and these forces will change the momentum. Okay, so boy will gain momentum in the forward direction, girl will gain momentum in the backward direction. Both of them, they had initial momentum 0 because they were at rest in the beginning. Okay, so boy's momentum is in the forward direction. Okay, and boy into V boy, and girl momentum will be in the opposite direction v. Okay, so we can say 0 is equal to initial momentum is 0. Boy plus girl, both of them were at rest. So total initial momentum was 0. Equal to 0. Boy plus girl, both were at rest. So this was 0. So final momentum will also be 0. So 0 is equal to m boy velocity, mass into velocity plus mass of girl into mass of velocity of girl. Okay, so we can get the velocity this way. We can take it to the other side. Minus mgvg is equal to mbvp. Okay, so that was a little elaboration of the example which I just discussed with you. Now the topic is cars safety features. Rear crumple zone. Okay, that is backward in the backward direction, backward side, rear crumple zone, front crumple zone. What else is there? They are just being labeled. Airbags, rear seat belts, front seat belts, side impact bars, and collapsible steering wheels. Okay, so the steering wheel collapses when some car hits some wall or any accident occurs. So it will keep the person safe from any injury. Okay, because the person who is sitting in on the driving seat, he will of course continue moving with the due to inertia. When car comes to rest due to any collision with the wall, the car will come to rest. The person due to inertia will move continue moving, and he will hit the steering. So here steering will be collapsing, increasing the deceleration time. Person of course is going to decelerate, but he will take some time to decelerate. So when the time is longer, the person will come to rest in longer time. Okay, so force will decrease. So it means rate of change of momentum will also decrease. So force acting on the person will decrease. Okay, increases the time taken for a driver or passenger to change the momentum to 0. Of course, initially the momentum of the driver was same as the momentum of the car, which was in motion, but finally the momentum becomes 0. So total force is equal to momentum change divided by time taken. So momentum change in momentum of the person divided by the time. So final momentum is 0. Initial momentum is what? Mass of the person who was sitting on the driving seat into his velocity. Velocity is same as that of the velocity with which the car was initially moving. Okay. So longer time. So these are the safety belts. This is a dummy shown here in the figure. Car hits the wall or something, and the dummy driver here, he continues moving forward due to inertia and hits the steering wheel. So there is a crumpling zone, some compressive material, so which will prevent the person's head from getting serious injury. So rubber tile used for playground flooring. Okay, so explain how these can reduce injury to the children. When a child falls to the floor, its momentum changes from a high value to 0. Okay, so and he comes to rest slowly. So time will increase. Okay, increase the time taken for this to change. So force is equal to change in momentum, final momentum minus initial momentum over time. Time is longer means force is smaller. Okay, force acting on the child is reduced. Now the force exerted on an object is equal to the dash. Force exerted on an object is equal to the change caused by cause divided by the dash. So equal to momentum change caused by the time taken for the change. Airbag activates during a car crash. The inflated airbag dash increases the time taken for the drivers or passengers velocity to fall to zero. The time taken for their momentum to fall to zero is also increased. Therefore, the force exerted on the driver or passenger is also decreased and potential injury may not be caused. No, because when two bodies collide, they apply force on each other. Like the example which we discussed, the lorry's example or the example of the girl throwing the boy, they all are having Newton's third law of motion involved in them. Okay, so force has the same size and acts in the opposite direction. The girl's force on the boy was towards right, so boy's force on the girl was towards left. It means action reaction forces always act in pair. Okay, act in pair means they act on two different bodies. Lorry's force on the car, car's force on the lorry. The force will be the same. Amount of force will be the same, and the time for which the force act will also be the same. So, according to Newton's third law, to every action there is an equal and opposite reaction. Okay, the bodies are different here. Okay, so boy and girl are exerting equal and opposite forces on each other. Okay, the forces are of the same type. It means they are applying here pull force. If one is applying pushing force, the other will also be applying pushing force. Okay, the type of force will be the same, magnitude of force will be the same, direction will be opposite, and the time for which the forces act will also be the same. Rocket in flight. So here, rocket, there is again example of forces in pair. Gun and bullet example also has the same thing. Okay, so thrust of the rocket engine, A. Okay, so downward on the ejected gases. Okay, so ejected gases are ejected out, and as a result, they apply force on the rocket, and rocket is moved forward. Okay, so the B is the contact push of the ejected gas. That is also push force, thrust here. It is applying push force on the gases, and gases are applying push force on the rocket. Okay, so direction is opposite. Tire and friction, third example. The force of tire, force of the road. Okay, force of tire on the road and the direction of motion is shown here. Okay, this is the direction of the tire in which it is moving. It is moving in clockwise direction. So the friction, of course, will be opposing, acting in this direction. Red color arrow shows the friction. Okay, so friction is providing actually the driving force. Direction of motion is the same here. Okay. So a car is able to move forward due to friction acting between its tire and the road. Okay, the force of friction of the road on the tire acts in the forward direction and is equal, but in opposite direction to the force of friction on the road. The friction of the tire on the road, that will be in the opposite direction. Now again, fill-ups. A dash is a push or pull. What comes here from this? Force. Okay. And the force can cause an object to accelerate or change the shape. Force is measured in newtons. There are many types of forces. Contact force occur when the two bodies touch each other. Forces always occur in pair. Okay. If there is a force, if a force is exerted on an object, there will always be another force equal in size acting in the opposite direction. Okay, so that is now end of the topic. And again, there will be a video which will contain the numericals from IGCSE classes and IGCSE papers and GCE O levels papers. Okay, so we will see each other again in the next video of momentum, that is momentum part 3. This was momentum part 2, in which we studied about the we studied about the conservation of momentum, Newton's third law, and different things. Allah Hafiz.